Vernier caliper used in every manufacturing industry all over the world for measuring the length accurately and precisely up to 0.02 mm. Now let's see this Vernier caliper is used in the 16th century and that one is used nowadays. Now let's see the history of the Vernier caliper inventor. He is the Pierre Vernier, born August 19, 1584 in France and died September 1638. He was a French mathematician and inventor of Vernier caliper. His father, also scientist, is a Claude Vernier, and this measuring instrument known as a nonius. How? This name came from the Portuguese astronomer and mathematician Pedro Nunes, and who had invented a related instrument in 1542. In the 18th century, this instrument is called as the Vernier caliper. Now let's see the Vernier caliper and its different parts. This is the external jaws to measure the external parts of the object, and this is the internal jaws to measure the internal measurement of the object. And this is the vernier scale, locking screw, main scale and depth measuring blade, which is used for measuring the depth and the height of the object. Now this Vernier caliper is used to measure the internal, external and depth of an object. Caliper measures an instrument with two jaws. This vernier scale and main scale is used by principle of different division of two scales and find the accurate and precision measurement. How? Let's see, this is a Vernier caliper and this is the main scale, and its one division equals to 1 millimeter, and this is a vernier scale. Its one division equals to 0.9 millimeter. Why? Because this is up to 9 millimeter and this is the 10 division. So that this 9 divided by 10 equals to 0.9 millimeter. How this list count is coming? This is the main scale 9 division equals to vernier scale 10 division, and this list count is the 1 millimeter minus 0.9 millimeter equals to 0.1 millimeter. So this is the list count. So another type of vernier scale, this is the main scale 49 division equals to vernier scale 50 division. So its list count means this 1 millimeter equals to 0.98 millimeter equals to 0.2 millimeter. How it is come? This 49 divided by 50, so it is equals to 0.98 millimeter. Now let's see the error of this vernier scale. If we attach these two jaws, so this vernier scale reading 0 should be matched with this main scale reading, this one. So this is the 0 error. Here this 0 and 0 is matched, and this is the positive error. So this 0 is not matched with this main scale. Some gap is there. So this positive error should be minus with the actual measurement. Now let's see the negative error, where this is the gap. So this negative error should be added with the actual measurement. This minus into minus means this is a plus. Vernier caliper list count by mathematical. Now let's see the difference between the value of main scale and the vernier scale. So this should be 1 minus 0.9 millimeter equals to 0.1 millimeter. So how it is come? It's come by another way. This list count equals to value of main scale division divided by total number of division of vernier scale. So which is the 1 millimeter is the value of the division, and 10 means this is the n of this division of vernier scale, total division of this vernier scale. Now this d equals to value of smallest division of the main scale, and v equals to value of smallest division on the vernier scale. This is the n minus n by n into d, and this is the list count. This list count means the d minus v. So this d minus n minus 1 by n into d. So if we calculate, then we will get this d by n. So this measurement equals to this main scale reading into main scale list count plus this is the vernier scale reading into vernier scale list count. So this is a digital vernier. Nowadays we are using this type of verniers. Now let's see the actual measurement process of this vernier scale. Now let's see this vernier scale, this main scale 1 division equals to 1 mm, and this is the vernier scale division. So here, from here to here, this is a total 20 division, means here the n equals to 20 division, and its least count of this main scale equals to 1 millimeter. So where it is matched, now this 0 is matched here slightly larger than this 25. This is a 20, this is a 5, up to 5, so you say this is a 25. So this main scale reading MSR equals to 25 into 1 mm plus VSR. So VSR means vernier scale reading how much? This is matched with where it is matched. Now that portion is perfectly matched. So if we see directly here, so 0.6, but if we calculate it with this least count 0.05 millimeter, then we will get 12 into 0.05 millimeter. So equals to 25 plus 0.6 equals to 25.5